Okay, hi everybody. Thank you for coming. Thank you for coming, even though I know there were already like six sessions mentioned in Langchain4j before me, and I have the honor to be the last of them. My name is Jan. I work at Red Hat. Right now, today is my 13th anniversary working at Red Hat, so this is a great way to celebrate that. I will talk about the stuff that I've been involved with for the past half a year, and that is the integration between Quarkus and Langchain4j. Even, as I said, there were already some sessions about Langchain4j, so I will focus mostly on the Quarkus side of that, and how Quarkus can make that stuff easy to use and cool. So you already know this. How do you submit questions? So I can just skip that. The agenda. Yeah, first, what is Langchain4j? I'll skip through that very quickly. Why use it with Quarkus? Well, obviously, that's the main goal of this session, is to persuade you that it's a great fit to use them together. I will have some demos, how to get started with that really quickly. I'll show you how to use Retrieval Augmented Generation. That means boosting an LLM with your own data. How to do it the easiest way that Quarkus allows you to. How to do it in an alternative approach without embeddings, but using SQL instead. I think that will be very interesting. I will show you, metrics or generally observability, what Quarkus gives you about your LLM applications, and Dev UI. That's the stuff that Quarkus gives you to make your life even easier. Well, you will see. So what's Langchain4j? That's a library that provides some abstractions for working with different types of LLMs. By different types, I mean we have abstractions for chat models, we have abstractions for embedding models, image models, and stuff like that. It has integration with Spring Boot and Quarkus. Yeah, we'll focus on the Quarkus side here, and it's all available on this in this GitHub repository. So the abstractions provided by Langchain4j. So as I said already, chat model, that's what you use to communicate with something that allows you to chat. So that's GPT, Llama 3, and all these things. We provide an abstraction for chat memory. That's an object that encapsulates the memory of a previous conversation with a model, because models are stateless. So when you chat with it, and then you send one message, you get one message back, and when you want to continue that conversation, you have to send back the whole previous memory again, because the model doesn't obviously remember it itself. We support text-to-image models, where you provide a textual description what you want the model to draw for you. We support embedding models and embedding stores, which is important for Retrieval Augmented Generation. Then there's this concept of AI services, which basically and tools, which means you can create some, let's say, type-safe APIs for communicating with chat models, and give it tools to create autonomous agents that can decide to call your own code, as I will show you how to let an LLM execute your own code. There's also an abstraction for moderation models, which is something that can detect inappropriate content in messages. And of course, we support multiple providers. So OpenAI and Ollama. What else? I have a list here. The supported providers. So OpenAI, Ollama, Hugging Face. If you know, Hugging Face is kind of I would call it GitHub for LLMs, where people upload different models, and you can download them or have them hosted directly from Ollama, from Hugging Face. And we support talking to these models. We also support talking to models deployed in Red Hat OpenShift AI, IBM Watson X, IBM Business Activity Monitoring models, Anthropic, Mistral AI, Google Gemini. That's a lot of supported models. Of course, not all of these providers support all model types. So for most of them, we support obviously the chat models. For some of them, we have embeddings. For others, moderation. For others, image generating models. But this is obviously something that's evolving very, very quickly. So this list obviously isn't exhaustive, and it's growing very fast. And this is also only listing the providers that we have directly integrated in the Quarkus extension for Langchain4j. The Langchain4j upstream project supports even more of them. We just haven't yet integrated them. So you can use, even if you use Langchain4j through Quarkus, you can use those models, those providers too, those that aren't first-class citizens integrated into Quarkus. You just don't get the first-class integration like unified configuration, CDI integration, and stuff like that. So why should you use Langchain4j with Quarkus and not standalone? I already mentioned integration with CDI and our configuration model, where everything can be configured in a single properties file. You get build time initialization. I hope you're at least somewhat familiar with Quarkus and what it does at build time. You get out-of-the-box support for GraalVM native image. You get observability out of the box. It generates metrics, fault tolerance is integrated, distributed tracing, and stuff like that. Development mode, of course, you have hot reloads with Quarkus. We provide UI that you can use to play around with models. I will be using that in my demos. That UI has the nice feature that you can use it with any supported model. So we have a unified UI that you can use for chatting with GPT models, Ollama models, or whatever other chat models that we support. All the demos that I will show are available directly in the GitHub repository of the Quarkus Langchain4j project in the samples directory. I just changed them just a little bit to be more suitable for the demo. But other than that, it's pretty much the same. So let's get now to demoing. The first demo is how to get started extremely simply using JBank. If you're not familiar with JBank, it's a tool that allows you to write scripts with Java. Basically, Java applications contained in a single source file. I will show you one such source file, and I will show you how to run a bot that can tell you jokes in just 12 or 13 lines of Java. I hope you can see it properly. So this is a file named jokes.java. And it kind of works as a fully self-contained application, Quarkus application, through the JBank integration. It has integrated these dependencies, so it kind of works. As I said, it can bring in Maven dependencies. Here, you just declare all the dependencies as comments instead of having to write a POM XML. And then you write your code. With the Quarkus integration, the easiest way how to get started is to just add a dependency on Quarkus, which is the first two dependencies, then Langchain4j with the Langchain4j extension for Quarkus, and in particular the OpenAI extension that brings in support for OpenAI, because that's what I will be using in my demos. And then you just listen to the start event of Quarkus, and you, in this case, I take the vertex router, which is the component in the HTTP extension, where I can register handlers, HTTP handlers, and I register just a blocking handler on the joke path. And the handler, what it does, it takes an injected model. That's the chat language model. That's injected from CDI. And I just tell the model to tell me a joke, and the model will just tell me a joke. And now you simply execute this stuff by going to the right, going to the right directory, and now you write jbank jokes java, and Quarkus will start. Quarkus started in less than a second, and now you simply can call that endpoint, and it will connect to the OpenAI API, GPT 3.5 in this case, and it will tell you a joke. It always tells this joke, almost always exactly this one. No. Okay, I've seen this one like 50 times. Okay, so what next? Now I will tell you something about AI services. An AI service is a Java interface with some predefined prompts that you can use to, talk to the chat model in a somewhat type-safe way. It makes it more type-safe because you can map the responses directly to Java POJOs. So in this case, in this example, I have a very easy AI service that represents a robot that handles bookings for a hotel. And it has one method, create booking, with some parameters of information about the person making the booking. And it returns a booking object. And that booking object is just a POJO class with just some fields like name, email, start date, and date. And you specify the user message that gets sent to the LLM when this create booking is executed, and it says create a booking for name with that email from start date to end date. And what it will also do, because you declared the method to return booking, then that means that the Langchain4j engine will also automatically scan that booking class and tell the LLM how to exactly format the response so that it will be possible to map the response to a booking object. So it will tell the LLM, please respond in a JSON format with these fields, and the model will respond with these fields in JSON as a JSON document, and then the response will be mapped directly to a Java POJO. Okay, now let's get to Retrieval Augmented Generation. If you want to feed your data to an LLM, how do you do that? You have a lot of documents that might be relevant to answering a user's question, right? Let's imagine you have thousands of documents, and a user asks something, and some of those documents contain information relevant to answering that question, some of them don't. Well, what do? You can't just slap up all the documents into the request, because that would be too much data, too much irrelevant data. LLMs have a limit on the number of tokens, so you would overwhelm that, and it will get would get also too expensive because those that charge you per token, which is most of the online ones, yeah, that would mean a lot of money that you will be charged. So you can't just slap all the documents as the context to the request. The solution is to use the embeddings. I will just quickly explain because I assume you already are kind of familiar with that. You take an embedding model, which is something that takes a text segment and maps that to a vector, n-dimensional vector. So that means coordinates in an n-dimensional space. In a way that documents that are semantically similar will have a very similar vector with low vector distance between them. And you store these text segments along with their embeddings with vectors in some kind of embedding store. I will also explain soon what that can be. And then when a user asks a question, you simply take the embedding model again and run the same for the question. So you also transform the question to a vector. And then when you're trying to find the documents that might be relevant for answering the question, you simply take run a vector similarity search, k nearest neighbors, and you find n documents that have the most similar vector to the vector of the question. And you retrieve these documents and slap these up to the user's question and send these documents, these text segments, together with the user's question with something like this. Here's some information that might be relevant for answering. That's pretty much exactly what Langchain4j does by default. Just it looks exactly like this. So yeah, about the embedding stores, we support a lot of different embedding stores. You can use all different kinds of databases. We have Redis, we have PostgreSQL. If you install the PG vector extension for storing vectors, there's Pinecone, that's a pretty popular option right now, nowadays. Qdrant, Infinispan, Neo4j, the graph database. There's also an in-memory embedding store, which obviously doesn't scale well, but I will use it in the demo because it's extremely easy to get set up with just a simple in-memory store. And yeah, of course, this is just like with the model providers, this list is growing very rapidly. So, demo number 2. How to get started with RAG the easiest way. We have something called EasyRag. And with EasyRag, you simply create an application. I won't create it from scratch. I already have it here because it's in the samples. It's called chatbot EasyRag if you want to try it later. And how it works is that you have a Quarkus application and you put all the documents that you want to be stored in the embedding store. You just put all the documents that you have in a single directory in your file system, and it will scan all of them on startup. And you don't have to provide pretty much any code. It will just you just have to provide an embedding model, and it will even generate an embedding store, an in-memory embedding store by default. If you want to use an actual persistent embedding store, you can do that. But if you don't provide one, it will just use the in-memory store. As you can see, I have 4 documents, for files here, and they are in different formats. Because we use Apache Tika, which is a library that allows you to parse different file formats. So you can use plain text files, you can use PDFs, ODTs. If you have the Tesseract library installed in your system, you can even use images and it will run through optical character recognition to extract text from those images, and that text will be stored in the embedding store. So let's start it. I will switch to the right, which one? Chatbot Easy Rag. And I will start it in dev mode. So it's starting, and on boot it will automatically. Yeah, I should mention that there's one configuration property that you have to provide, and this is this one, the one on line 2, Langchain4j easy rag path, and there you just specify the path where all your documents are, and that's it. Then you start the application, and it will, if you look at the log, where is it? Yeah. Here it says, yeah, Tesseract is installed, is being invoked. It means that it found Tesseract and tried to OCR my documents, but I don't have any images there. And the PDF contains just text, not images, so it didn't have to really OCR anything. And then it tells you that it ingested 4 files as 8 documents. This is these 4 files in the catalog directory, and 8 documents because when a file is obviously too large, we won't store the whole file, but we will split it into segments. In this case, what the files contain is some information about the products of a fictional bank. So there's some information about some savings accounts and about minimum opening deposits and stuff like this. So let's try it. How do you actually try it? That's another great feature of Quarkus that we have is the dev UI. Yeah, this application actually has its own UI, but okay. Let's first try the UI that comes with the application. Let's ask, I don't know, minimum opening deposit of a standard savings account. I will ask that. And yeah, it found the right document and says that the minimum deposit is $25. Now let's try the same, but not with the UI that was explicitly created for this application. Let's try it with the dev UI that comes with Quarkus out of the box. We have this great thing called dev UI. And there, when you're using Langchain4j extensions, there will appear some more pages that you can use in the dev UI. One of them is the chat, page, and yeah, I forgot to mention that there's an AI service. I should show that. This bot that answers questions about banking products is an AI service. And there's just again one method that just submits a question and returns a string, nothing special there, and it tells the robot that it's an AI robot named Bob that answers questions about financial products and blah blah blah, and some instructions how it should respond. What it should do if it doesn't know the answer and stuff like that. So this is called a system message that gives the LLM some starting context, some instructions how to talk to the user. So if I open the dev UI, you see that I have this system message automatically populated here. That only works if you have a single AI service and a single system message right now. Which is the case right now for simplicity, and so the dev UI was able to fill that for you, so you can easily, if you write a message here, you're basically talking pretty much to this interface, to this bot. So I can ask the same question again, and let's see what happens. It will show the system message first. That's the system message that it tells the AI, you are named Bob, blah, 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 blah. And then there's my question, what is the minimum opening deposit of a standard savings account? And now you see that it actually augmented, you see here in the dev UI, you see the augmented message that contains the data retrieved from the embedding store. So it found some, I think by default it looks for 3 text segments and slapped them up to the original question. And yeah, here it says that there's an opening, here it says that there's an opening deposit of $25. And so or maybe it's this one, I don't know which one was the most relevant, that doesn't matter. It gives the model the right the right context, so the model then can respond that the minimum deposit is $25. Okay, what do I have next? Yeah, now let's just quickly show how to use a persistent embedding store. For example, I will show you how to switch to Neo4j, because why not? Because that's quite cool. It's a graph database. You might not view a graph database as suitable for vector search, but it works. It's something that we've added quite recently. You just add a new dependency. You just add a dependency on the Neo4j embedding store. And yeah, you will also need to specify some more configuration. You need to specify the dimension of the vectors produced by the embedding model, which depends on the embedding model itself. In our case, it's 1,536 because we're using text ADA embeddings from OpenAI. Yeah, and let's tell it where to exactly start the Neo4j container. It will start Neo4j as a container because we are using dev services, and I'm just fixing the port where it should sit. And now I can connect. I see that it actually started a Neo4j container. I can connect to it. Hopefully it will work. And if I look into the database, you can see that there are 8 documents in the database. And for each document, you see here the fields, the embedding, that's the big array of numbers, 1,500 numbers. And the text is there also stored. So you see that it automatically populated the embedding store on startup. Okay, then next I would like to show a different approach to rank. For now we used embeddings, and that was like the most basic approach how to do rank. There are more advanced use cases. We just used a content retriever, an embedding store content retriever that retrieved the embeddings from an embedding store. But it can get more complicated. You can use a query transformer that reformulates the query to extract some more precise question and remove unnecessary context and stuff like that. I will show that in a minute. Then you can route that through a query router to different content retrievers. Obviously, each content retriever can be a different type, so it doesn't have to use an embedding store. It can use whatever else, like a relational database, which I will show in a minute. It can use a different LLM. You can use a full text search engine, whatever. So you can use multiple content retrievers. Then you aggregate the content found by all these retrievers, and then you inject that. And then a content injector injects the result, the aggregated contents, into the original question. And all these blue things together are called a retrieval augmenter in our terminology in Langchain4j. And that retrieval augmenter produces that augmented user message, and that user message is sent to the LLM and contains all the necessary context for the LLM to be able to answer. So I will now show you an alternative approach that uses SQL instead of embeddings. I think I really love this one. I think it's pretty cool. I'm not completely sure it will be super useful, but yeah, I think it's cool. So I'll show you. So how it works? How does it work? It is that user here. Let's start from the top and go to the bottom. The user sends a question, and together with the previous history, previous memory, of previous chat memory, we give that to a query transformer to reformulate the question. Why do we do this? It might not be completely necessary, but for example, if you have if a user asks, I don't know, about one particular film, I don't know, Inception in this case, asks a question, what's the rating of the movie Inception? And then the LLM retrieves from the database something, retrieves the rating and a response. Then the user sends a follow-up question about the same film, but doesn't repeat what movie he's asking about. So he just asks, when was it released? And the query transformer will take the full history and reformulate the question, when was it released? And will reformulate to something like the release date of Inception. And by that, we can increase the accuracy of how the LLM will be able to generate a useful SQL query to answer the question. So when we have the reformulated question, we ask the LLM to generate an SQL query. Actually, really, we tell the LLM generate an SQL query that can answer this question, and we give it as context. We give it the information about the database. So we give it a list of tables, or in my case, just a list of columns, because there's just a single table. And the LLM generates an SQL query. Then the content retriever executes the query and obtains the result set, the relevant data that might be relevant for answering the question, and adds this data to the question in a JSON format. So let's just go and show it in practice. So which one is that? Is this one? Is the CSV chatbot? Yeah, we should definitely rename that to SQL chatbot. I don't know why it's still named CSV. So where do I start? Yeah, so this is an example that answers questions about movies in a database. We have a database that contains information about movies. It's populated from a CSV file. This is the CSV file. There are some movies. There's a name, year of release, category, runtime, genre, whatever. And there's like 100 of them. On startup, we automatically take this CSV file and put it in a relational database, in this case, a PostgreSQL. So, and then how will it work when a user asks questions about films? So we have, again, an AI service, and that AI service is declared to use this so-called movie muse retrieval augmenter, which is what I was talking about in the previous slide. And that retrieval augmenter, what it does, it injects a model, the chat model, injects a movie database content retriever, which I will show now, because the content retriever that's the component that takes care of locating the right data. So what it does, the content retriever, it receives a query that was first reformulated by the query transformer, And it asks the LLM in the background, it asks the LLM to create an SQL query. I will show you how that exactly is done. Here you see that it asks the LLM something like this. Create an SQL query to retrieve data necessary to answer the user's question using data from the database. Blah, 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 blah. The table has the following columns. And here we provide a description of the schema that we have in the database. Answer only with the query and nothing else. And what this will really do is that the LLM responds with the query, then the content retriever actually executes the query, retrieves a connection from the database, executes the query, and then transforms the result into a set of JSON documents. And these JSON documents are then added to the user's questions. So let's, without further ado, let's just quickly run it, because we don't have that much time as far as I can see. Which one is that? Yeah, CSV chatbot. Run it. Quickly. It's starting a Postgres database again as dev services, and it ingests the 99 movies into the database. And now it started, so I can start asking questions. I'll again use the dev UI for that. So I will, what is the rating of the movie Inception? And first the raw question appears here, but when it's done, it gets replaced with the augmented message from the retrieval augmenter, and you see that it added answer it using the following information, and this is the JSON document. But okay, why didn't it answer properly? Great, that's how it always works with demos, right? It got the right data, but it didn't answer. Okay. I'll try using this UI that's directly for the application. I'll just try it again. And now it worked. I don't know what happened. Of course that worked. That always happens. And just to show how the query transformer works, when was it released? And I ask, when was it released? And if I look into the log, you see that, yeah, let me just find it, the reformulated query. Yeah, question to answer rating of Inception movie. That's the previous question. And yeah, and there's the reformulated question, release date of movie Inception. You see, that's how the query transformer transformed the query into something that's concise and doesn't include any unnecessary context. And this is the actual SQL query that was generated by GPT 3.5. Yeah, this is using GPT 3.5. So it generated an SQL query. It was then we executed that and added the result as JSON documents. Okay, let's go on because we're running out of time. Tools. How to allow an LLM to write your own code, to execute your code. Let's go to the example. Which one is that? That's the email a poem. Yeah, that's an application that tells the LLM to write a poem and send it via email. Okay, to be able to receive that email, I will actually run a mock SMTP server. Yeah, and I will also run, because I then later want to show you tracing. I will also run an OpenTelemetry collector. So now we have a running mock SMTP server here, and and we give the LLM access to some tool. Tool is a method that you wrote, and you allow the LLM to execute it. And in this case, where's the tool? Yeah, here is the tool. Here we have a method annotated with add tool. We provide the description what this tool does. It sends the given content by email. We keep it very super simple. By only requiring the content as this only parameter. The destination address is hard-coded here, and the subject is also hard-coded. So the LLM will simply provide the poem, which will be the content. So there's again an AI service. The AI service has a single method here, and that says write a poem about a topic, and this topic will be hard-coded to Quarkus, actually, because we have this REST endpoint that calls the service and executes that method with the topic of the poem should be Quarkus, and the poem should be 4 lines long. So let's execute that. This will be which one is that? Here, this one. Did I start it? No. Let's start it. Cool. It has this very simple UI, and you click email me a poem. It will write something, dump it here, but also send it by email. And so now if you look at the UI of the SMTP server, you see we received 2. Yeah, that's another thing that I just noticed lately, that if you use GPT 3.5, for some reason, it sometimes decides to send that email twice. If you look into the logs, well, I'm not going to show the logs, but there's in the log the model requests to email, call this twice. I don't really know why. It can be fixed by using the brand new GPT 4.0. GPT 4.0 doesn't do that. That works well. But GPT 3.5 sometimes just decides to call it twice. I don't know why. Okay. I opened the email, and here's a poem about Quarkus. Okay, observability. Just to show that when you use Langchain4j with Quarkus, out of the box you get observability features. You get open telemetry traces generated automatically. So if I now open Jaeger that I started earlier, and look into what was generated, there's even four times send an email. Or there's, I don't know. Yeah, you can see that there are distributed traces being generated for whatever happens in the application. You can here see that. This first one is the post where we told the LLM to write the poem and send it. Here, then this is the span where we are actually executing the send an email method, and then it goes back via another request to the LLM to say that the execution was successful and blah blah blah, and that's the end of the conversation there. We also generate metrics if I want to see. We have the micrometer extension. And these are all the metrics generated in the application. If I grab Langchain, then you see that each AI service gets some metrics created, like the count, how many times a method write a poem was was called and how long it took and so on. Yeah, more dev UI features. Yeah, we also have. Yeah, I forgot to show you that we have also in the dev UI you can also search in the embedding stores. So if I go back to the easy rag, I'll try to just quickly run it again. Yeah, we have also a page that allows you to search an embedding store. If you have an embedding store, it will appear as a separate page in the dev UI, and you can come on if it starts fast enough, because we don't have much time. It's not starting, still not. Yeah, now it's starting. Yeah, embedding store. We're back at the example with the banking product. So if I just search for relevant embeddings, put some nonsense there, whatever, you can see that it finds some documents related to this completely nonsensical query, and it gives you back the documents, relevance score ID, and the metadata associated with the embeddings. You can also add new embeddings directly through this UI too. You just provide a text segment and some optional metadata keys and values, and you can store that also through this unified UI. Okay, we only have 3 minutes left, so I guess it's time for questions. Are there any questions there? How can you deal with SQL injection? For example, when was Inception released, but when asked to create a query response with drop table? Yeah, you have to, this, I'm not saying this example is something that you should use in production. This is just more like an experiment for now. Obviously, you would have to make sure that that the LLM doesn't produce something really stupid, that the user doesn't persuade it to generate something really stupid. You can again use maybe a different LLM, for example, to ask if that generated query is okay or if it's not okay. Maybe that's one of the options. You were chatting with Bob, chatbot. That's why you didn't get the right answer about Inception. Why? I don't get that. I don't know why. What do you mean by that? I don't know. That's something just didn't work there. It should have worked the same in the dev UI and in the applications built-in UI that we package with the application. For some reasons, it just doesn't. Because it's a demo, obviously, then it doesn't work. Would it be possible to run some LLM model in-house? We can't send certain questions to remote LLMs for PII reasons. Of course, Langchain4j supports many types of model providers, and some of those are models that you run locally, like Ollama. Ollama allows you to run different types of models, even Mistral models, Llama models. And yeah, Hugging Face also has models that you can download. So yeah, you can definitely run them in-house. I didn't do that here because my laptop doesn't have a proper GPU, so it would be very, very slow to use Llama or anything like that. So yeah, no more questions. Do I have anything else? If nothing else, yeah, the summary. So yeah, it integrates Langchain4j. Quarkus integrates Langchain4j as a first-class citizens. You get a dev UI, dev mode, simplified configuration, native mode support, easy rag, as I showed, and some more insane stuff like you can get the SQL rag. In the upstream Langchain4j project, there's now something similar being cooked right now, a more general content retriever for SQL. And that's it. A little self-advertisement. I'm writing a book about Quarkus. If you're interested in learning about Quarkus, you can get this book with 45% off if you use this code specifically for GeeCON. And with that, we're out of time. So I'll look if there are any more questions. You can take pictures. Did any more questions arrive there? Nope. Okay, then thank you.